Right, so this is part 2 of, well, from yesterday, carry on from yesterday. So let's just crack on. So in the previous video, you were just looking at or discussing meshing up some alternative structures for this costume jewelry crucifix and the loop. So based on the way that this was 3D printed, so now we can see the annotations on the screen. So based on the way that this was 3D printed and based on its size, it basically meant that we only had a couple of layers of FDM plastic to define this shape, which meant that it wasn't very strong and was prone to breaking. Now the weak points would generally be here and just this loop, but with it being plastic, its weak point was basically the entire top of the loop, and it was prone to either breaking or snapping. So what we've done, or what's been done, is taking a look at doing some alternative loops that should work, but changed the profile, but basically kept the hole roughly the same. Change the profile to make them much more robust relative to, let's enable shape smooth, get rid of all the faceting. So we did that design and we did that design. That changes a little bit actually. So edge select, scale, let's scale this a little. Oops. Just make it a little bit chunkier. So this differs, the two designs differ in the sense that we've got a little flare out at the bottom of this one, which should in theory give it more area or a larger connection area between the crucifix and the loop versus the other one, which just is slightly wider at the bottom, but there's no fill or bevel. So it'll be interesting how that will translate into 3D printing. So what we need to do next, so this is going to be, let's just save this, this will be the designs that we will test. So we've got that one and we've got that one. So what we need to do now is export these. So that's what we've got. We need to export these and then check them in the 3D printing slice tool so that we can see a projection, which is basically pretty accurate actually, a projection of what it'll 3D print out like. So all we need to do for that is just select our components. We don't need to join them. We don't necessarily need to join them together into a single uniform mesh. We can leave them separate. because the STL will combine them, but depending on the slicer we may need to join them. So if we needed to do that, let's just check the so that's the crucifix. So let's just think. Let's just give this a easy to see which is right. So 2, so that's 3. That's 2, so add that to 3. Generally speaking, you want to make sure your subdivisions, if you're using them, are relatively uniform. So select. Let's try exporting them as separate units first. So they're separate meshes, but it will be combined in the file as two, well, we'll see. So file, export, and this will be as STL. Export as STL. So settings, we want selection only because our file has a ton of stuff in it. Everything else is okay. And let's call this version 2. Yeah, version 2. Export, just double check, everything's okay. So again, selection only. We'll just export STL. So that should apply the modifiers. We don't necessarily need to do anything with that. So in the slicer, let's check that file. So we want to, where do we put it? Where do we put it? So models, 3D print. That's a 3D printer. So we've got the STL first. Where is it? Oh, there it is. So there's our file. Open. So it's super tiny, but we can adjust that. So select our mesh or the object, and depending on the settings, that's super tiny. But depending on the settings, because so it's going to be small relative to Blender because Blender's unit system has been set up for millimeters, but when you import a file from Blender with millimeters set up as your units, whatever you're importing them into, so where do we set units? It is scene units. So unit scale, we've got that set up for millimeters. Length millimeters. So when you import something, it'll go a little, well, whatever you're importing it into might not understand Blender's units, so it'll come in tiny, but depending on the slicer we can adjust that. So select our model, scale, set 4.5. Let's just go 200. Still quite small, so millimeters. So that's 30 millimeters. So let's go with 40 millimeters. So we need to make some adjustments to the mesh because we've got some open surfaces which it doesn't like. Let's just do a quick slice on that. So your model is not manifold. The highlighted areas indicate either missing or extraneous surfaces. Let's just do a quick slice. Preview. So that's what we're going to see. Now, so this is interesting because what this is showing is obviously the structure of the print, and we can see the striations. And this particular layout is not good for what we're doing because these striations are weak points. So for something like this, what we would have to do, select our object, we need to rotate it so that it's lying flat on its back or front, because we need the, let's slice that again, let's do a preview, we need the structure of the print to add strength to our mesh, well not the mesh, to the final project. So the stress is, what is that, vertical relative to the object being used, whereas before it's horizontal, so it's going across the shape, which is a weak structure. But we need to make some adjustments to that. We can see 32 minutes, 3 grams, or just over 1 meter of medium. So back to Blender. TikTok. So we need to. So as we saw, you don't necessarily need to join your meshes together because the export-import process will essentially see them as a single object. But so hide that. We need to make sure that our meshes are all closed. In other words, they don't have any holes in them. So if you imagine these as solid, well, if you imagine these as balloons filled with water, they need to be made in such a way that the water can't leak out. So another bit on that, I have to just do more editing. That's okay, enable that. Now we have to get the position correct. I'm doing gaps, so what we can do to make sure that we are positioned correctly is just slightly embed that in the surface. And what was it saying about extraneous surfaces for the crucifix? It doesn't matter about that because that's a closed surface. Yeah, that shouldn't make any difference. I'm not quite sure why is there erroring out on that. So let's re-export. File, export, STL, override, selection only again. So selection only, scale. We can fiddle with the scale here if we want, so let's try that. So let's go with, let's multiply that up 10, apply modifiers, and then just export. So re-import that, open files, and it was the STL, that one, open. So it's brought in a second version, so we can leave this one in place just so that we have a comparison. In fact, let's just stand that upright so that it's so slice the two of them. So we don't have any errors. So how big's that one? It's 67. That's okay. Right, so lay that down. Move that one aside. Well, lay that one down as well. Oops. Slice. So again, we want to make sure that we create as much structural strength for the loop as we can by realigning the objects. So even if, or even as we've essentially made this so that it's standing upright, we don't necessarily need to create more work for ourselves in Blender and make the object relative to how it's going to print or relative to how it's going to be placed when it is being printed, because in the slicer we can change the orientation of our objects, their scaling, their positioning, and all sorts of other things. Slice. So that looks okay. So that design is that one. So let's export the other one. So same crucifix but different loop. So same again, so loop, crucifix, export, STL, version 2B, same settings, so selection only, and we'll keep the scale. So actually one thing before we do that, yeah, one thing we want to keep in mind. So in the slicer, It's telling us the object is, let's go to the scaling, it's telling us that the object is 67.435, so it's basically 67.5 millimeters. So when you're 3D printing, you need to be aware of decimal places relative to your printer's ability and its accuracy in printing out decimal placements of millimeters relative to the size of the printer head. So these lines, or these layers, are roughly 0.2 of a millimeter thick. So when you're doing your printing, or when you are setting up your printer, you're going to get the units of measurement relative to how accurate, or it's basically the printer's, the nozzle size of the printer. For the printer that's being used to print these, it's 0.2 of a millimeter. But if you're using resin, it might be a completely different setup. Or an older printer, it might be 0.5 of a millimeter. So a newer FDM printer might be able to do 0.1 of a millimeter. So you need to keep in mind that these measurements, although you may be making something that's accurate in Blender, you need to be mindful of avoiding, and we need to make some adjustments to that. You need to be mindful of making sure, as best as you can relative to your design, that you are using whole numbers. Or, so if the printer nozzle, because you have to allow for medium spread. So even though the nozzle on the printer is technically 0.2 of a millimeter wide, the medium that comes out of it, because of the heat of the nozzle itself and the heat on the printer plate, it'll spread. And that spread might actually end up meaning that a single line of medium that's printed onto the plate is actually 0.3 or 0.35 millimeters wide, not 0.2 as it comes out of the nozzle. So when you make something, you have to keep that in mind, that you might be making something that's fundamentally accurate in terms of millimeter measurements to whatever it is that you are wanting to print, but your actual print may not be the same because of the tendency of the medium to spread. So if you want ultimate accuracy, you have to keep in mind that you want to try and avoid decimal places. So with that in mind, let's make some minor adjustments to this, because so which is that one? That's one. Hide. So the grid, if I remember correctly, these are millimeters. Is it millimeters? Yes, it's millimeters. Yes, 1, 2, 3, 4, 5, 6. Yes, that's right. So it's millimeters. So this is 60 millimeters high. So this now is right. So one major grid is 10 millimeters, and each one of these smaller ones is 1 millimeter. So that's now 8 millimeters high. So we should end up with a crucifix that is, here's a custom jewelry that is, and we need to make sure that that's buried. Import Crucifix, and then just make this select, let's go to that. Let's just save this file, so increment. And then export for printing, so select, file, export STL, call this B, as we were going to. So same settings, so we just want to export the selected meshes, keep the scale at 10, it's going to apply the modifiers for us, so export STL. Right, so we can import that into our slicer, so these are the originals. That's the first design. File, open file. STL. To be noticed. Open. So there's the updated design, so let's just make these upright. Oops. And then slice. So those are the two designs. So we can see what we were talking about, that we need to be mindful of the orientation of our print, or the object that we're going to print, so that we give it as much strength as possible for this loop. So right now, obviously, all of these layers are weak points. This is where it can pull apart if we leave this in its upright position when it's printed. And it'll be the same for the crucifix arms as well. This joint, or this join, this connection will be a weak spot. We will get a weak spot when we flip this so that it's lying on its back, but it'll orientate the weak spot on the arms. So if we now rotate this, rotate, position on the plate, slice, this is going to be to see, but so that's the second design, and that's the first design. So it's going to be interesting to see which one. No, I can't quite. It's going to be a little tricky to try and get this on screen. But as I was saying, the horizontal alignment of the layers now gives this much more strength than if it's standing upright when it's being printed, which means the then horizontal layers would result in weakness. So the next thing to do would be to print these out and see. Wow, so that'll take 4 hours to print both of these. And these are, how big are they? 60mm. So let's get rid of the small one. Delete. Reslice. Have to reposition them slightly because they're going off valid printer space. So let's just move those. We don't necessarily want to place our objects at the center of the build plate every time we do something, because you're essentially burning in that central area where your prints keep happening all the time. So if you can, just offset your prints, or the meshes, objects, whatever, to be offset on the build plate. So I need to change the settings on this. Wall thickness, that's okay. So what we need actually is standard quality. And where is that? That's off. We need supports. So that will generate supports for slice. Because obviously printers, FDM printers at least, can't print overhangs, so they need to put supports in. Whoops. They need to add supports to print overhangs. So we need to add those. So standard print, I think we'd use the, we've changed the quality. That was dynamic. So a standard print is only going to be only 2.5 hours for these two objects. And that will, wow, 7 meters of medium. So let's, so that's 3 wide. So what we could do here is infill, that's okay, shell, wall thickness. So what we can do is change the wall thickness. So if our printer nozzle is 0.2 millimeters, so let's go with 1 millimeter. So that's a line count of 2. So that now means if we re-slice these, what we'll find is that we now have just 2 layers, which that's not really using that. I mean, it's taking maybe 20 minutes off the print time and half a meter. So most of your print material is going to be consumed with the fill, with the structural fill that's needed for it to support itself when it's doing that top layer of print. Otherwise it'll collapse on itself, because obviously the 3D printer can't print unsupported structure. So that's going to be interesting to see. Just a quick check of something. Alright, so I can turn that off if you need it. Right, so that's going to work. So those are our two designs previewed in our slicer. So this is what they're going to basically print like, and we can see that our loops, let's do it this way around. You can see our loop designs and the difference between the two of those. So it'll be interesting to see how that prints. So let's just save this to file. So is everything okay? So that's position is okay. That's right. Right. So save the file. So this is going to save a G-code file. Yeah, all of this okay. G-code. And I'm just going to save this properly as a local project. Blah blah blah. So that we can reload this back into the slicer. So next step will be to print these and see what the results are like. So yeah, that's using Blender to make some modifications to a loop and a piece of costume jewelry that broke. Basically, it's too easy to break this sort of design. So from a wearable piece of costume jewelry, from the point of view of printing your own costume jewelry, you have to keep in mind that these things do affect the longevity of the bits and pieces that we make. This wouldn't be such of an issue if this was being made as an object that was going to be cast, so a mold, because you, in that instance, you are just making this in Blender to be printed so that you can then process it for casting. So this might, obviously with the striations, as we can see in the slicer, the print will pretty much look like this, in exactly the same sort of layers and striations that we can see. Those do appear, although they're not quite as obvious, they do appear in the print. So if you were doing something for casting, you would get your print once it's printed out, and then you would use your various media or mediums, so plastic fillers or fillers in general, just to fill out and smooth all of this, which you would then cast in, I don't know, silicone or plaster, if it was a one-off, to produce your, if it was silicone, you would cast it in silicone to create your wax. Is it a positive or negative? Yeah, so the silicone is a negative, so that's your negative mould. The wax that you then pour into that is your positive mould, which you then encase in plaster for casting. But this sort of thing doesn't necessarily matter. It only matters if the end result is the costume jewellery that's going to be printed. So the print is the costume jewellery. So that's it for now, for today. Might do some other live streams about all of this stuff using Blender to make 3D prints. But we'll see. Right, so thanks for lurking, lurkers. Thanks for hanging out, all the hangers outerers. And we shall see you on the next live stream. Yoink.